Assalamualaikum and hi everyone. I am Aqilah binti Ghani from UTM. Today I am going to bring you all to my project. Let's take a look on my title. Potential of recycle by axially oriented polypropylene pellets as fine aggregate for concrete. Wait, is there any relation between BOPP and concrete? Let's take a look on this. The construction is the largest industry in many countries, largest consumer of raw materials, while plastic waste is a versatile material that may be used as an aggregate, but must fulfill the application of mechanical and durability standard in construction. Also should be affordable and sustainable to promote its use. Several studies has demonstrated their potential to improve concrete qualities. Example of PW that has been used are polyethylene terephthalate, polyvinyl chloride, polystyrene, and low density polyethylene. Later investigation on BOPP as a building aggregate. Therefore, this project will be focused on using recycled BOPP as fine aggregates in M20 concrete mix. To start off, this project is all about aggregates. Ashraf et al. 2011 has stated that the land masses used for mining or quarrying for aggregate production will no longer available. Rahman et al. 2009 also reported that strength of concrete produced using PWA is far lower than produced by natural aggregates. PWA concrete is typically made by replacing several polymer forms such as natural coarse or fine particles of the same bar or amount through direct volume replacement, and utilizing modified polymer aggregates from plastic waste would be a promising step to improve the strength, stated by Mohamad et al. 2022. There is still limited study focusing on studying the effect of adding BOPP as plastic waste aggregate in concrete mix. The compositional factor of PWA will be the primary variable to be investigated. It is due to its cruciality to the concrete workability strength. The objectives of the project are to identify the greener option for concrete manufacturing and aggregate use in construction, and to investigate the potential of BOPP as plastic waste aggregate against natural aggregates through formulation effect for the workable concrete mix. This study focused on the effect of PWA to NA ratios 0 to 100 and 10 to 90 for the M20 concrete grade. The methodology for this study are, according to table 1, the M20 concrete were hand mixed, and then the sand was laid on the platform and cement was poured over it. In dry condition, the sand and cement are truly mixed with shovels number of time until the material achieve an equal color and streak free. Recycled BOPP and coarse aggregate was placed in homogeneous layer on top of the mixture and well mixed. 75% of water was poured into the depression and stirred using shovel. The remaining water was added and mixing procedure was repeated until concrete had a consistent color. The overall duration should not exceed 3 minutes. All the specimen preparation and curing procedure are follow the British standard. Fresh concrete mix was filled in 100 x 100 cm mold and repeated ran to produce homogeneous cube, also cured in water for 7, 14 and 28 days. After that, is tested for compressive strength followed by British standard 2. The compression test was performed at room temperature using hydraulic press compression machine, and the fracture concrete mix were investigated using optical microscope. This analysis is to determine the aggregate distribution. For the result, the figure 1a shows that M20NA showed acceptable workability, whereas M30R BOPP showed otherwise. Sample slumps value falls within acceptable range, but produced mixture may have less stability and some mixing might collapse. Because RBOPP is non-hydrophilic surface and reduce the interface transition zone. Figure 1b shows the compressive strength of both M20 concretes of 7, 14 and 28 days. Graph showed a similar pattern of reduction as 1a. The hydrophobic surface of RBOPP aggregates cause a thin water flow, diminish the M20 RBOPP strength compared to M20 and A, but still the compressive strength showed good values with average of higher than 20 MPa. The highest CS at 28 days could achieve 50 MPa. The limited hydrophilic surface of RBOPP could be compensated by the homogeneous size of dispersed aggregate between NA and mixture. Figure 2 shows the fracture surface of concrete cubes. The whitish RBOPP aggregates in 2B are dispersed between the natural aggregates. For the conclusion are the workability and compressive strength test conducted on M20 concrete showed that RBOPP had promising potential to replace the natural aggregates. The uniformity level of RBOPP aggregates influence the CS values. Further modification to RBOPP aggregate surface could improve their interaction with the other elements and enhancing the mechanical properties and concrete performance. This is the reference for this project. Thank you.